So we started looking at chapter 4, and remember, some of you might remember, I showed you some graphs, and we looked at like starting points, and those starting points were our y-intercepts, and we looked at things like who had more baseball cards, and graphing, comparing, and stuff like that. So they all dealt with functions and linear functions, and then I told you guys we would do linear functions, which were straight lines, and we would do nonlinear, okay? So today we're going to go back and look at linear, and then Friday will be nonlinear, so that's not going to be straight lines. It'll be curved lines and stuff like that, okay? So the first definition, and you can underline it, highlight it, whatever you guys want to do, is called mapping. And mapping represents two sets of objects or items. Two sets. So there's one set in the left side, one set in the right side, and an arrow connects the items together to represent a relationship. So see how there's arrows? So like this 1 goes to the 7, 2 goes to the 1. This is called mapping. And if we want to write these as ordered pairs, all you would have to do is say that the left side represents x and the right side represents y. So this would be 1, comma, and see how it points to 7? We would put 1, comma 7. And then the next one is 2, and 2 points to 1, so 2, comma 1. 3 points to 5, and 4 points to 3. So far, so good? So just make ordered pairs from these two sets of numbers. Now, sometimes you're given the set. These little squiggly brackets, what they mean in math is it's a set of these numbers. It just means like a number set. And so if I want to work backwards, I'm given the number set. I draw my two ovals, so draw this on your paper too. Okay, it doesn't have to be perfect, obviously, mine are not. And then I want to list all the x values on the left, so I'm going to circle my x's so that I don't mix anything up. And I have 5, 11, 6, and 8. And then on the right, I have the y values, so that's 8, 9. There's another 8, so I don't need to rewrite that. And then 5. So if you get repeating numbers, you don't have to write them more than once. So now let's draw our arrows. So 5 goes to 8. So draw an arrow from the 5 in the x over to the 8 in the y. 11 goes to 9. 6 goes to 8 as well. And then the last one, the last 8, goes to 5. Okay, so both of these represent linear functions. These are, if you graphed these, you would get a straight line. Okay? Now, a relation, right here, a relation is any set of ordered pairs, that would be these, or the mapping between a set of inputs and a set of outputs. Remember, x is input, y is output. Okay, so that's a relation. The first coordinate of an ordered pair in a relation is the input, the second is the output. So you can write up here x, y if you want to remind yourself. Does anybody remember another word for x's and y's? We learned before break. The x's start with a D. Do you remember? No? Anybody? Dependent, independent that's another one, but in this section I told you another one. We wrote it in our notes and I had you write definitions. D and the R, and the X is a D and the Y started with an R. Anyone remember? It's on this paper. What? Domain. Good. So let's write domain under here so you can remember that's domain. And this is range. Okay, so if I wanted to write these as ordered pairs, I would just write negative 10, 20. Do you guys remember this? And negative 5, 10. I'm not going to make you write all of them. If it said to list the domain and the range, my domain, I would write like this with that squiggly set bar. And domain, I would just list all of my x values. And we always list them in order least to greatest. So this would be negative 10, negative 5, 0, 5, and 10. And the range is all the y values. Again, least to greatest. But you can see that I have repeating ones, right? I have 20, 10, 0, 10, 20. So all I have to do is write 0, 10, and 20. I don't have to write them twice. Okay? This one over here is basically the same thing. They just flip the x's and y's. And that's okay. So your domain over here would be the range. And the range would be the domain, like if you flip-flopped them. But there's a little bubble here, and it says, so all functions are relations, but only some relations are functions. This sounds like something Dr. Seuss would say, or Shakespeare maybe. No, not Shakespeare, but what's the guy, Willy Wonka, when he says weird things? So all functions are relations, but only some relations are functions. It all depends on the domain and range, and I'm going to explain that. Okay? So the next section says a function, underline function, maps each input to one and only one output. I'm going to show you what that means. In other words, a function has no input with more than one output. The domain is the inputs, the range is the outputs, okay? Remember, input is x, output is y. So let's look at this one right here. The domain, I'm not going to make you rewrite it, but the domain is this, right? I'll put D for domain, 1, 2, 3, 4. The range is 1, 3, 5, 7. Put R for range. Now, the definition of a function says that it maps each input, that's this side, to one and only one output. And that would mean it's a function if it's doing that. So we need to figure out, are these three all functions? Is one a function? Is one not a function? So what do you guys think for the first one? Is everything going to one? Yeah? Oh, sorry. Is everything going to one number on this one? So let's check. 1 goes to 7, 2 goes to 1, 3 goes to 5, 4 goes to 3. Are they all 1 to 1? Okay, so this is a function. Okay? Now, the second one. Again, we have our domain and range. So, again, I need each one on this side to have one number over here. So 1 to 1's fine. What about this 2, though? 2 is going to 3 and 2 is going to 5. Is that 1 to 1?
No.
No. So this is not a function. Now, see down here where you have 4 going to 7 and 5 going to 7? That's okay. The output can have more than 2. It's just the input. The input, so the x's, cannot have 2 arrows coming out of it. Cannot have more than 1 arrow, really. Okay? So if you get numbers here that like repeat or something like that in the input and the x and the domain, you probably know it's not going to be a function. You don't even have to draw it out. You'll just realize, oh wait, there's more than one. Okay, what about the last one? We have our domain and range. Are there any 2 lines coming from any of the x values?
No.
No, so this is a function. Even though the 1 over here on the y side has 2 arrows going into it, they're coming from 2 different numbers on the y, so this still makes it a function. Okay, so you're mostly concerned with looking at the left side or the domain values to see if they're repeating. Okay, so let's flip that over. There's this visual test that's really easy to use, and you guys will use it for the next, I don't know, however many years you want to do math. You just always use this test. And it's called the vertical line test, so you might want to underline that. It's really simple. It's basically what this says is it's a way to look at it, and if you draw a vertical line, remember vertical line is straight up and down, it cannot go through 2 points. 2 points on your graph. If it does, it's not a function. If it doesn't, it is. So like look at the first one. If I draw vertical lines through these points, do any of them connect?
No.
So this is a function, right? If I draw vertical lines on the other graph, do any of them connect?
Yes.
Yes. So this is not a function. And then if you want to look further, you can see these are the inputs. See how it says input on the x axis? And that's 2 4s, right? So 2 4s in the x are going to tell me right away, not a function. This is just a really quick way to look. So you don't have to look at the numbers, you could just draw straight lines. Okay, let's look at m. Raise your hand if you think it's a function. Raise your hand if you think it's not a function. Okay, it's a function because each one has a separate number it's going to, right? What about n? Raise your hand for function. Raise your hand for not a function. Good, just write not. There's 2 arrows coming out of the 12th. Okay, what about O? Raise your hand for function. Raise your hand for not. Raise your hand for I don't know. Okay, let's look at it. Are there more than one input that are the same? They're all different, right? So this is a function. Easy, right? How about P? Are there any repeating values in X?
Yes.
Yes, so is this a function?
No.
No, so write not. Not. So far, so good? Does it seem too simple? Yeah, it is that simple. Okay? How about S, the set of ordered pairs? So let's see, are there any, I can just circle all my X's. Oh, what's going on? They're all 2s. Is this a function or not?
No.
Yeah, good. How about T? I'm going to circle all of my X's. You see that I'm really only concerned with my X's every time? My domain? Does anything repeat there?
No.
No, so it is a function. And then U looks weird. Has anyone ever seen this graph before? The x squared graph? I don't think you've seen it. But this is what it looks like. I'll draw it for you. This means it starts at 1 because we know the 1 is the y-intercept. Remember that from the regular straight line graph? But an x squared is a parabola. Have you heard that word? It makes a U shape. Okay, but I'm going to show you how you can test. Now I could do a vertical line test, right, and see that it is a function. But if you don't know what the graph looks like, what you're going to have to do is choose 3 values. So do a t-chart. We did a little of this before break. Put -1, 0, and 1. Now if I plug in -1 for x, that's -1 squared, which is 1, plus 1, so I get 2, right? If I plug in 0 for x, what do I get? 0 plus 1, so 1. And 1 for x would be 1 plus 1, which is 2. So is this a function just based on my x values being different? Yes. I have 2 of the same y, but that's okay. You just can't have 2 of the same x. Okay, so if you're not sure, just plug in 3 numbers. You can plug in any 3 numbers. These are just the easiest. Okay? And then you're going to get these as word problems too, of course. But it's really not that bad. You can do the same thing. This says this equation is used to calculate the number of inches in a foot. So y equals 12x. All you guys have to do is make another t-chart. Do -1, 0, 1. So when x is -1, what is y? Anybody? -12. When x is 0, what is y? 0. And when x is 1, what is y? 12. See? They're all different. So this is a function as well. Any questions? Pretty simple stuff. Okay. So what you guys are going to do in your practice, which I'll give you about at least 15, maybe 20 minutes to do, is the first part you just need to map. You can draw a line or write the letter, but match to your definitions. The second part, I want you to list the domain and range, just how I did it right here. Domain and range. I just want you to get used to that, okay? Just do it for the first one though, because once you do the first one, you'll realize like this is really easy and repetitive. But on all of them, I do want you to say whether or not it's a function. So write yes or no. So the first one, list the DR, how I did right there. just to practice, and then after that, just write yes or no. The second one, you don't need to list the domain and range, even though it says to, but what I want you to do on this one is I want you to draw the ovals and practice mapping. Okay? And then write yes or no if they're functions on those 4. And then on the back, use the vertical line test to say yes or no. Is this function? They actually put the line there, so is it? If I draw a straight line, vertical line, does it only touch one point?
Yes.
So this is yes. How about that one?
No.
How about that one?
No.
How about that one?
Yes.
How about that one? Ooh, you decide. Okay, so I'm going to pass those out for you guys.